Hello there, and welcome to the episode number 16 of Dev Conversations by SwiftToolkit.dev, where we host developers that contribute to the Swift tooling and server ecosystem. Today, our guest is Moritz Lang, a developer based in Berlin, and he created the Swift OTel package. OTel stands for OpenTelemetry, established observability standard in the industry. And this package just reached its 1.0 version after 4 years in development. Hey Moritz, how are you?
Hey, good to see you. I'm great. How are you?
Good. Thanks for joining the show. I watched your talk that you presented along with Simon, right, in the last Swift server conference.
Exactly.
And was very, very good talk. I recommend
Thank you so much.
anyone watching. And we'll leave links to it in the show notes. Tell me a little bit about how you started programming and a little bit of your career.
Yep, sure. So I started programming back in 2013-ish. My sister introduced me to it back then. Before it, so I was mostly focused on music, football, and that kind of stuff. But then I got into programming, and as you noticed, in 2013, right before Swift was announced in 14, I started with like typical full stack web, JavaScript, PHP on the back end. But then once Swift got announced in 2014, like I really got interested in iOS development. Swift was way more approachable. Like I looked at Objective-C before I started programming. It was so off-putting that it didn't even cross my mind to do iOS development. But then Swift made it way more approachable. So 2014 was kind of the start of like working with Swift. From then on, I worked as an iOS developer, both as a freelancer and full-time employee. But for me, it's especially once Swift got open source and Swift on the server started becoming a thing, it was always that like if my main job was iOS, then I wanted to do server side on the side and vice versa. So I kind of have to have both. Not necessarily at the same job, but yeah, open source and
I totally understand. I also, whenever I'm doing too much iOS, I like playing with the latest on Swift on server.
Yeah, totally.
Yeah.
And then in 2017, I moved to Berlin, studied software engineering, and then that led to me during one semester I worked with observability tooling. That was around the time that OpenTelemetry emerged. And then coincidentally, I did Google Summer of Code in 2020. And my project there was creating the Swift distributed tracing library. Google Summer of Code was, or still is, a project where Google brings together students with open source projects. And Swift is participating, I think, since 2018 or so.
And did you apply for it?
Exactly, yeah. I applied on the Swift forums. It was the perfect timing for me because, as I said, in that semester, I worked on observability already at uni. And then one of the proposed projects on the Swift forum for GSOC
was this.
Swift distributed tracing. So yeah, as I said, perfect timing. So I applied, was very lucky to get in and had an awesome experience there. And then out of that became the Swift distributed tracing library. We can go a bit into the different observability libraries, but basically, we also talked about this in the talk. They're only an API, so you still need...
Yeah, they don't have real implementation.
Exactly. So you still need additional actual implementations that then send telemetry to different places. So just building the API layer for distributed tracing, like that was great, but it didn't, like we didn't have a use case or example like showing it working. So very early on, I then started prototyping Swift OTel, and then I think in 21 I made it open source. Had a couple of refactors since then, especially Swift Concurrency was a pretty big impact, going from like Swift Neo's event loop future based API to not having event loop features at all in the API.
Did it make things easier or harder?
It made things way easier in this case, especially around gracefully shutting down the library, so that if your server stops, for example, you're still exporting telemetry. That was way easier to model with also Swift service lifecycle once that switched to async. And then, so I would say on the server side, it had a really nice impact. On iOS, my experiences so far have been so and so, but overall, I'm quite impressed by the Swift concurrency system.
And did you have any experience on other backends besides PHP, for example? Like, how did you even start getting approached to OpenTelemetry, and how did you begin?
Good question. So in that uni project, we were working on a microservice-based architecture, and I really wanted to use Swift for that because at that point I already fell in love with it quite a bit. So we used Vapor microservices back then, and there wasn't a story for tracing around it. So I started investigating, then some of code came to be, and so on. And then like pretty much right after I finished Summer of Code, I started working at Broken Hands, which is an agency by Tim, the maintainer of Vapor. Exactly. And there I worked on a couple different server-side Swift-based projects. And one of those projects was really nice because we got to actually integrate the then pretty new Swift distributed tracing library and the Swift OTel prototype in production. And that also provided a lot of like insights towards like the roughness of the API in the early beginning. Back then, for example, we didn't even have task locals to propagate things throughout the context. So it was a nightmare. We had to manually pass around different objects, had to fork every library to then continue passing it along and so on. But Swift concurrency made that also way nicer.
I'm sure. Yeah, I think it's important for people who didn't watch the talk yet. But there are basically three main pillars of telemetry, right? Or at least OpenTelemetry. One is logging, the other is metrics, and tracing. Yes. So logging, most iOS developers are aware of what it is. Like you log things that happen in your code path, so you can understand what's going on. And on servers, you send these to some other server maybe, or you just log it to the standard output. Metrics is numbers, gauges, and tracing is and also distributed tracing is kind of performance analysis. What parts of a specific requests are taking longer. Yes. So as you said, there are the API packages which are only they don't really implement. So yeah, let's talk a little bit about what exactly you implemented was.
Yeah, so the API packages for SwiftLog and SwiftMetrics already existed before I started distributed tracing. And that was, as you said, like getting the three pillars done was the only missing link was distributed tracing back then. And generally speaking, the way these API packages are structured is that you have the user and library facing APIs. So you have libraries such as Vapor, for example, if they log, hey, we started listening on port, blah, blah, blah. They would use SwiftLog, like a logger from SwiftLog, and then say logger.info, for example. And then by default, that log would get to standard out. But as you said, you may want to send it elsewhere at production.
For example, like real services.
Different tools, Datadog. There's plenty of tools. But since there are plenty of tools, it's not in SwiftLog's domain to be able to export to all of them.
Yes. Mm-hmm.
Exactly. And then the same holds up for SwiftMetrics and Swift distributed tracing. So with SwiftMetrics, again, Vapor, for example, you as the end user, you would create counters and increment them and so on. But SwiftMetrics itself doesn't know where to export the metrics. And then for Swift distributed tracing, it's similar. You create what's called spans, and then spans are these operations that make up the larger requests. And then Swift distributed tracing again doesn't know where should I send these spans. So that's pretty much what I did with Swift OTel. In the beginning, it started out as just exporting spans from distributed tracing via OpenTelemetry's protocol to any backends that supports this OpenTelemetry protocol.
Yeah, and it's all a standard, right? It's
exactly.
It has many, like you can choose how often you want to send. You can choose the sampling rate, because maybe you don't want to send 100% of the events or metrics, because it might affect the performance of your server. For people who might not be familiar with the term observability, what that means in practice and how is that important in production systems?
Yeah, if you have a production system, it doesn't matter which size you're operating at. In the end, you don't want to get bug reports from users or failed payment handling and that kind of stuff. You want to know upfront if something's going wrong, because always things will go wrong, but you want to be in a position where you are the first to know about it, so you can address it potentially even before your users are actually facing the issue, or before it affects the entire user base. So observability is, to me, like a practice and a set of tooling that allows you to as the name implies, to observe what's going on in production at runtime. So you fix the bugs at compile time, and that's all great, but then at runtime things will end up going wrong, but you want to be able to notice when they're going wrong.
And maybe set alerts.
Exactly. Yeah.
And when you started working on Swift OTel, what did you tackle first? And did anyone from the community join you? Why did it take so long, also 4 years, to reach 1.0?
Yeah, that's fair enough. So as I said, I started with distributed tracing support only, because Swift OTel was naturally born out of the necessity of having an example implementation for Swift distributed tracing. Right while I was working on Swift OTel, the OpenTelemetry standard itself was also work in progress. I think that tracing for them also was the first signal that they standardized. And I think back when I started, it wasn't even stable yet. And then throughout the years, they added more signals. So they added logging and metrics over time. And that's also how I started getting contributions in Swift OTel. So once people started noticing that Swift OTel is quite handy for distributed tracing, they naturally wanted more. So that's when
the full
picture. Yeah, exactly. And that's when Sai came into the project, because he was really interested in getting SwiftMetrics support into Swift OTel. So the ability to export your counters via OpenTelemetry standards. And he contributed a huge chunk of that project. And I was in the lucky position to just review very well-defined PRs and got to merge them along the way. But for me, it was also sometimes tough to spend a lot of hours on Swift OTel, because at that point I was working full-time, again, as an iOS engineer.
A little detail that you also have a job.
Exactly, yeah. Happens. So I spend as much time as I can, and also want, honestly, on the side on open source projects. So it's awesome that I got the opportunity to work with collaborators on the project, and people are genuinely interested in improving the library and using it in production. But I think, the combination of like not having enough time and OpenTelemetry emerging over the years,
Plus Swift Concurrency.
plus Swift Concurrency, that fun refactor.
Yeah, fair enough.
So yeah, at least we're now there, and I'm very happy, especially with the like public API refinement that we did for the 1.0. Like maybe some of your listeners experimented with Swift OTel before we hit the 1.0, and the library itself was very configurable, as you said, like sampling rates and all that. But you, in the end, needed to plug 10 different objects together, set them up in the right way, and really have to know about the internals. And all of that has gone to a single line now, where you just say,
Bootstrap.
I want to bootstrap observability, and you get logging metrics and traces exported by default. And it's still configurable, but the barrier of entry is just very low, which is, a pretty exciting change that also Sai contributed a lot to in the 1.0.
I hope to get either a video or a post about it, about how to get started with. I started playing with it, but I didn't have the time to get it done.
Mm-hmm.
In my case, I opened an account in Grafana, which they support all of the OpenTelemetry standard, but I could choose, as you mentioned, Datadog or probably Sentry as well.
Yeah, I think Sentry just recently announced some like native OpenTelemetry support, if I remember correctly. But yeah, it's the de facto standard at the moment. Like every big observability tool does support OpenTelemetry.
Yeah. And another little implementation question is, I found the distributed tracing is pretty impressive, because you can, let's say you have 5 different microservices, and the user requests something in the first microservice, and this request can go to these 4 different services before it gets back. How do all of these microservices know, for example, how this is the same request? How Swift OTel knows how to connect? Because basically they're running in different services in different places, right? They're not
exactly.
How does it work behind the scenes?
Yeah, I'm happy to go into that. So the first thing you have to understand about distributed tracing is it's based on these spans. But when you start a span in distributed tracing,
how can we define span?
Span, define it as it's an operation that takes X amount of time, and you give it a name. So it could be authenticate the user or persist your favorite programming language. Whenever you start a span, what distributed tracing libraries such as Swift distributed tracing do is they check, is this the so-called root span? So when your first microservice is hit, then that would be the root span. Like that's where your request originates. And then that also starts the trace. So at this process where you start the span, we generate a couple of random identifiers. One for the trace ID, so the overall request cycle, but also span IDs, like for each individual span.
For each child.
Yeah, for each operation, let's say. Exactly. And then it could be that, like, for example, if you're using Vapor or Hummingbird, they have distributed tracing built in. So they would create the root span for you. Could be /hello, for example, for the request handling itself. And then imagine in your handler, you call a database client. And then that database client internally would also start spans. And as I mentioned earlier, back in the days, for these spans to be connected, we needed to pass manually this set of identifiers throughout everything so that we can link them together.
Connect the dots, yeah.
Exactly. But once we got task locals via Swift Concurrency, we could make this way more implicit. So now you create a span in Swift distributed tracing, you or a library that you use. And then as long as you're staying in structured concurrency, even 10 methods down your call stack, if that also creates a span, then it will notice that there is already a task local that provides these identifiers, and then is automatically linked without the need for passing anything around. But that still is only on one process, right? So the next bit is, how do you take this to go distributed? Basically, what you're doing there is whenever you hit a boundary, such as one server makes an HTTP request to a different server, you then take this task local context, stuff it into HTTP headers or gRPC metadata, or could be anything depending on which transfer you're using. You put it in there, and then on the other side, your next microservices, whether it's implemented in Swift or Go or whatever, it knows, because in let's say in this example you're using the OpenTelemetry standard, it would know which header to look at in the request to re-extract this context. And then it's just the same story as if you start spans in the originating microservice. So you create new span IDs, but it keeps this overall trace ID. And then you just configure each microservices to send data to the same observability tool.
Yeah,
and then this observability tool can link it and visualize it.
Yeah, it's gonna put the pieces together and assemble the puzzle.
Yes.
Yeah, and present this data in a nice UI that you can drill down, and so on. Very nice. Okay, and to wrap up, what are you excited for the future of Swift on server? What is next for Swift OTel?
I'm very excited that I got the feeling, especially attending this year's server-side Swift conference, that the ecosystem is evolving and it's maturing quite a bit. In the early days, we lacked libraries for pretty much everything. But now it feels like it's more of an exception if we don't have a library for something yet. There have been a couple of interesting announcements. For example, Swift Configuration was one revealed at the conference, which I'm quite excited for. Like, once all of these different server-side and also client-side Swift libraries start adopting Swift Configuration, that will provide a huge jump in like configurability at runtime as well.
Yeah, that's something also I forgot to ask you. Swift OTel supports many environment variables, right? You don't need to manually configure everything. As long as you provide environment variables, you're good to go.
Yeah, you can stay with the single line of code if you want to, and just supply tons of environment variables. Most of them come directly from the OpenTelemetry specification itself. So, for example, if you want to set up the endpoint to where you're sending telemetry, you can also just read the OpenTelemetry documentation, or that backend documentation on how to set up OpenTelemetry, and just plug in these environment variables, and it will work with Swift
your
OTel.
bootstrap is still one line.
Exactly.
But with Swift configuration, you'll be able to use that package in Swift OTel, for example.
The other way around, like Swift OTel could define a bootstrap that would work with Swift configuration. So the premise of Swift configuration is that you can have different providers of configuration. So, for example, you could say, I want to configure my entire service via a single YAML file. And then that could contain also your OTel configuration, which would then be translated into Swift OTel. So that's something exciting. Then I think next for Swift OTel or observability in general, is integrated the libraries that don't have it yet. I mentioned earlier we have built-in support in Hummingbird, Vapor, Valkey. I think you had an episode on or a post on Valkey.
A post.
That one had distributed tracing support from the get-go. The new temporal SDK also has built-in observability support, but there are still a couple of libraries such as Postgres Neo, for example, that should gain distributed tracing and generally observability support. So yeah, it's the more we add it to these libraries, the less you have to do as a user to get even more observability into your system. Yeah, generally exciting stuff.
All right. Very cool. I hope to get this getting started with Swift OTel ready soon. Maybe as a video, maybe as a post.
Yeah.
For people who want to follow you, read more about what to do online.
I'm on Mastodon and GitHub. You can find me at /mo on both.
Yeah, literally SLASH / written.
/ like
right?
the /
Yeah.
and then
Yes.
MO, exactly. Yeah, quite lucky with that username that it was still available pretty much everywhere. Yeah.
Cool. All right. So congrats for such an impactful work on the server domain. And thanks for joining. See you around. Bye-bye.
Thank you, posting. Ta-ta.